In the present video, we will discuss the how to solve the unbalanced transportation problem by least cost method. Let's see the problem. Use least cost method to find initial basic feasible solution to the transportation problem using data of example. Here given the different supply centers and demand centers along with the unit cost. Let's see the solution. First, we have to check the given transportation problem is balanced or not. Here total supply is the 15 plus 45 plus 25, so which is equal to the 85, and total demand equal to the 21 plus 42 plus 17 plus 20, which is equal to the 100. So total supply equal to the 85 and total demand equal to the 100. Then total supply is not equal to the total demand. So given transportation problem is unbalanced. Here observe the total demand is greater than the total supply. So balance the given transportation problem. We have to add a supply center. Then we have to add a dummy row along with the unit cost is 0. And supply in the dummy row equal to the total demand minus total supply, which is equal to the 100 minus 85, which is equal to 15. So we have to add a dummy row, that is S4 row, with unit cost is 0 and supply is 15. Now once again I have to check the total demand and total supply. So total demand is the 21 plus 42 plus 17 plus 20, which is equal to the 100. And total supply equal to the 15 plus 45 plus 25 plus 15, which is equal to the 100. So total demand equal to the total supply. So given transportation problem is balanced. Next, to apply the least cost method to find the initial basic feasible solution. First step is select the cell with the lowest unit cost in the entire transportation table. Here lowest cost is the 0 for S4 row elements. Among these elements, we have to select the randomly. So that randomly selected element is the 0 for the S4 row and D1 column. So next we have to allocate the maximum feasible quantity to this cell. So this cell we have to observe the supply and demand. So here supply is the 15 and demand is the 21. So among the 15 and 21, maximum possibility of allocation is the 15. So we have to allocate the 15 here and subtract this 15 from the supply as well as the demand. Then supply will become the 15 minus 15 equal to the 0 and demand is the 21 minus 15 equal to the 6. So next we have to eliminate the S4 row because its supply is the 0. So we have to eliminate the S4 row. So then once again I have to repeat the same procedure until the table is removed. So next once again I have to select the lowest cost in the entire the transportation table. Here lowest cost is the 1 for the S2 row and the D1 column. So in this case we have to observe the supply as well as the demand. Supply is the 45, demand is the 6. So here maximum possibility of allocation is the 6. So I have to allocate the 6 here and subtract the 6 from the supply as well as the demand. Then supply will become the 45 minus 6 equal to 39 and demand 6 minus 6 equal to the 0. Then we have to remove the D1 column because its demand is the 0. Next to lowest cost is the 2 for the S2 row and D4 column. So I have to select the S2 row and D4 column cell. Here I have to observe the supply and demand. Supply is the 39 and demand is the 20. So maximum possibility of allocation is the 20. So I have to allocate the 20 in this cell and subtract the 20 in the supply as well as the demand. then supply become the 19 and demand is the 0. So now we have to remove the column D4 because its demand is the 0. So next to lowest cost is the 3 for the S2 row and D2 column. So here I have to observe the supply as well as the demand. Supply is 19 and demand is the 42. So among these two, maximum possibility of allocation is the 19. So I have to allocate the 19 here and subtract the 19 in the supply as well as the demand. Supply become the 0 and demand is the 23. So now I have to remove the S2 row because its supply is the 0. Next to lowest cost is the 4 for the S1 row and D2 column. So in this cell value, we have to observe the supply as well as the demand. Supply is the 15 and demand is the 23. So maximum possibility of allocation is the 15. Then we have to allocate the 15 here. Then subtract the 15 supply and demand. Then supply will become the 0 and demand will become the 8. Then we have to remove the S1 row because its supply is 0. So next to lowest cost is the 6 for the S3 row and D2 column. So here we have to observe the supply as well as the demand. Supply is 25 and demand is the 8. So among these two, maximum possibility of allocation is the 8. So I have to allocate the 8 here and subtract it in the supply as well as the demand. Supply will become the 25 minus 8, which is equal to 17, and demand is the 8 minus 8 equal to the 0. Now remove the D2 column because its demand is the 0. So next to lowest cost is the 8 for the S3 row and the D3 column. So here I have to observe the supply as well as the demand. So supply and demand both are the 17. So I have to allocate the 17 here and subtract the supply and demand. So 17 minus 17 is 0 in the supply as well as the demand. Then we have to remove this one. So now entire the table is removed. So then once again I have to rewrite the given transportation problem along with the allocations. So this is the transportation problem along with the allocations. Next, to calculate the total cost of the given transportation problem, and total cost is the, so unit cost is the 4 and allocation is the 15. So 4 into 15 plus 1 into 6 plus 3 into 19 plus 2 into 20 plus 6 into 8 plus 8 into 17 plus 0 into 15. Then total cost is the 60 plus 6 plus 57 plus 40 plus 48 plus 136 plus 0, and total cost is the 347. So this is the solution, and thank you.